now say by the completeness axiom, by C, sigma equals supremum of S exists. And now we want to show that that supremum is satisfying the equation. By the positivity axioms, there's only two possibilities. Either it's, well, three. Either it's, we're done. Either it satisfies the equation, or it gives you something that's less than 1, or something that's bigger than 1. So let's do these by cases. If sigma squared plus sigma is bigger than 1, we want to get a contradiction. How do we get a contradiction? We will lower the supremum. We'll find something smaller than sigma that is still an upper bound for the set, and that would be a contradiction. So how do we do that? Well, we just try some number smaller than sigma, and we don't know what it's going to be in advance, so we just write it as an equation. We're going to pick such a small number epsilon such that this is still bigger than 1. Right? So what epsilon could I pick to make this bigger than 1? Well, we should write this as sigma squared plus sigma, and now we fill in all the remaining terms. 2 epsilon sigma minus epsilon plus epsilon squared. So there I just expanded everything. And this is going to help me pick what is epsilon. Now, it looks a little messy over here, but I want it to be bigger than 1 in the end. So to make it bigger than 1, I can just ignore this. This is positive. Right? So let's write it as like that. Yes? I ignored the epsilon squared. So I get something like this. Why is this good? Because now I can use the Archimedean principle. I can pick my epsilon so that this thing over here is tiny. So that I get something bigger than 1. So let's say if sigma squared plus sigma is 1 plus c, it's bigger than 1, so it's 1 plus something. Okay, can you tell me what epsilon should be? What value of epsilon should I pick to make this bigger than 1? If I know that this is 1 plus c.
C over 2 sigma plus.
Right, good. C over 2 sigma plus 1. And that's it. Right? If I take that value of epsilon and I put it in here, that whole thing will be bigger than 1. So I found a value of epsilon, which is positive, such that now sigma minus epsilon satisfies the equation for the set. So that's a contradiction. So if sigma squared plus sigma is not bigger than 1, it's less than or equal to 1. The only problem is it might be less than 1. We want it to be equal to 1. So if it's less than 1, well, we're going to do a similar thing again. Let me not write it down. Let's just go through here and see how things change. If this is less than 1, let me try sigma plus epsilon. So how is that going to give me a contradiction? If I get that sigma plus epsilon squared plus sigma plus epsilon is less than 1, that means sigma plus epsilon is in the set. But that's not possible because sigma is the least upper bound. How can I have something bigger that's in the set? So I would try sigma plus epsilon here. And all of this becomes plus. These two become plus signs. I want the whole thing to be less than 1. So again, I have to try to figure what, what value of epsilon could I pick? Well, first let's say we want to pick epsilon small, say less than 1. Right? If you say you're going to pick epsilon less than 1, then epsilon squared can be just replaced with epsilon. Epsilon squared is less than epsilon, right? Epsilon's less than 1. So everything cancels except this, plus 2 epsilon sigma. So what should the value of the epsilon be? Well, if sigma squared plus sigma is 1 minus c now, then take epsilon to be c over 2 sigma. That's not the only way to do it. There are many epsilons you could choose. I'm just finding a way to give a value of epsilon. So that's it. That's how we do it. Okay. Epsilon's less than sigma over 2c. Sorry, that's not right. C over 2 sigma. Epsilon's less than c over 2 sigma, then sigma plus epsilon squared plus sigma plus epsilon is less than 1, which tells us sigma plus epsilon is an S, which is a contradiction. So finally, by positivity axioms, that's the only possibility. Any questions? Yes?
Epsilon squared when is equal to epsilon, but it's not minus epsilon, it's plus epsilon.
Yes, it's all plus. Everything here is plus. So this would be epsilon and this. Oh, I see what you mean. They don't cancel out. So you get over here 2 epsilon. Yes, you're right. And if you get 2 epsilon over here, then I guess you get. Well, it's just a matter of changing this value of epsilon. C over 2 sigma plus 2. There we go. That will be enough. So check that. Make sure you can do that. That value of epsilon will be enough. Okay, and that's how all these proofs go. Very easy, right? Of course, if I asked you to show that sigma to the 311 equals 2 as a root, then your answer to that question should be no. I won't. You can't make it. So my point being that I'm not going to ask you unreasonable, horrible calculations. Calculations will be like this. Alright, so that's that. Question 2. State and prove the Archimedean property of the real numbers. I'm not going to do it. It's in your notes. Please make sure that you know how to prove that. Then you want to show that the rational numbers are dense in the reals, and as I said, we can assume some fact there that I'm telling you that there's an integer from x to x plus 1, including x. And now you want to use that to show the rational numbers are dense. That's again in the notes. It's there, and then essentially in part C, what I'm asking is to see if you can actually apply the method that you use in the proof to find this rational number. Now, what I should have done here is that I should have said this. So let's suppose I will give you this extra information. Suppose that I don't know, let's say n is an integer between 10,000 times the square root of 1,000 and 10,000 square root of 1,000. So suppose I give you some value of n like that. My guess is it's about 300,000 or something, I don't know. But if I give you this, then what rational number would you give me? That would just be m over 10,000. Right? If m is an integer between here and here, and you divide by 10,000, you get a rational number that's between root 1,000 and the square root of 1,001. That's it. So, no calculators are allowed on this exam, so the question as stated without some extra information is not fair, because you'd have to compute square root of 1,000 and square root of 1,001. Alright, anyway, so that's the essence of the proof. Right? You take your interval AB, you want to find a rational number there, you multiply it by a big enough number until it has length at least 1. And then you apply the fact, this one, to find an integer there, and then you shrink it back by dividing by what you multiply by. That's it. That's how the proof goes. Easy to remember the proof, but you have to then write it down properly. Alright, so that's a median property. Alright, next we want the epsilon delta definition of the limit of a function. Again, please state that very precisely. What is it? For every epsilon greater than 0, there exists a number delta greater than 0, such that absolute value of f of x minus L is less than epsilon, whenever absolute value of x minus a is less than delta. That's it. That's the definition, epsilon delta definition of limit. And then continuity. That's even easier. What is continuity at a point A? The limit as x tends to a of f of x equals f of a. That's continuity at a. Okay? And now we want a proof, using epsilons and deltas, that the function 1 over 1 plus x squared is continuous at x equals 0. So exactly what it is, what is it that we're trying to prove? We want to prove this is continuous at 0. What is it that you're trying to prove?
That as x approaches 0 of that function is equal to 1.
Yes. That's what continuity would say, right? There we go. That's what we want. That's what continuity says for this function at the point 0, right? Any questions about that? You need to translate the question into a limit so that you can then use epsilons and deltas. Okay, and how do we do this? Well, we want to solve the inequality 1 over 1 plus x squared minus 1 is less than epsilon. So given any positive epsilon, we want to know when is that true. For what delta is that going to be true? So that will be true if we can do a little simplification, and we get that. Right? And what is it we're trying to get? We're trying to get the absolute value of x less than delta out of this. So this 1 plus x squared, we want to get rid of it. And we can. Right? Because 1 plus x squared is greater than or equal to 1. So we can just replace it with 1 and put an if. Okay, so if this happens, then this must happen.